Still working on ambiguous case. This time we're going to look at what does it look like if we do have two triangles. So last time it was just one, this time it's going to be two. Step one, set up your little table, the ABC and ABC. I know I need to use law of sines because I have an A and an A together. I know that it is angle side, angle side side angle, whichever order makes you happy, because I have to solve for big B as my first step. So sine 35 over 12 equals sine of big B over 16. Cross multiply. Divide by 12. And last, so if you ever get a decimal when you're typing things in because you thought you were done and you're like, that doesn't seem right, did you do sine inverse? So when you're solving for an angle, you must do sine inverse of that fraction to get the angle. Okay, so that should give you, I'm going to go ahead and round that up to 50 degrees. Okay. Again, could I keep going, go ahead and solve this triangle and then backtrack? Yes, that's fine. Problem I've seen doing that though is that we forget to go back and check, and then we just assume there's no second triangle and we're like, why did we get that wrong? So I always like to stop right here and check for that second triangle. So everything that was given is still given. And when I say given, it's like what was typed there as the original problem. For angle B, I'm going to do 180 minus 50. And that's going to give me 130 degrees. So I check that out. So can I have a triangle that has 35 degrees, has 130 degrees, has some room for a third angle, and it is still under 180 degrees? So we don't want it to bust. So 130 plus 35 is 165. So I'm good there. That also means that C here is 15 degrees. So second triangle works. I'm going to keep on working through to solve for everything. So this is kind of where you got to balance. Like I need all of triangle 1 solved. I need all of triangle 2 solved. Okay. So in triangle 1, I can easily find C by doing 180 minus 50 minus 35, which would give me 95 degrees. Okay. So now to complete everything, I'm going to find both little c's. Okay, so just take it one triangle at a time. So triangle 1, or we could say C1. We would do sine 35 over 12 equals sine 95 over little c. Cross multiply and solve. I'm not going to talk all of those steps out because at this point I have done it repeatedly. And calculator makes little c approximately 20.8. Triangle 2 is actually going to look almost the same. If you have one of these calculators where you can like go up and edit what you typed into it, it makes this problem much easier. So this time we still have sine 35 over 12, but this time we have sine of 15 over C, and I am in the way here, so let me scoot that over. There we go. Cross multiply and solve. So C is approximately 5.4. I have now successfully solved for both triangles, and they both work. Either one of these are possible if I have given the angle is 35 degrees and little a and little b is 12 and 16.